Solve problem on free torsional vibration of two rotor system.
Let us understand the concept of free torsional vibration in two rotor system with the help of diagram. In two rotor system there is the shaft with torsional stiffness Kt. So we will mention here torsional stiffness Kt for the shaft. And at the two ends there are two rotors, and these two rotors are A and B, and these two rotors is having mass moment of inertia. So mass moment of inertia for A is known as Ia, and mass moment of inertia for B is known as Ib. Now for this shaft is having, that is shaft material is having modulus of rigidity G. So we will mention here G. And again for this shaft is having polar moment of inertia. Now what is this polar moment of inertia? So when this rotor rotates or there is the vibration in the rotor, then there is the resistance from the shaft material, because this rotor is connected to the shaft, and that's why there is polar moment of inertia, that is J. So how to calculate this J? Suppose we will consider the diameter of shaft is small d, then for the shaft J is calculated pi by 32 d raised to 4. So this is the formula to calculate polar moment of inertia J. Now we will understand when the vibrations occur in this two rotor system. So when the two rotors rotate in different direction or in opposite direction, then only vibration occurs in this two rotor system. So because these rotors are rotating in opposite direction, amplitude of vibrations are also in opposite direction. So we will show here the amplitude of vibration for rotor A in upward direction, then the amplitude of vibration for this rotor B should be in opposite, that is in the downward direction. So A1 is in the upward direction and A2 is in the downward direction. So we will show here this is rotor A and at this point rotor B. Now the total length in between this A and B is L. Now if we join this A1, that is the end of A1 and A2, then we will get some point of intersection to the shaft, and this point is known as node point, that is N, and at this node point amplitude is 0. Now if we measure the distance of node point from this rotor A, then it is known as LA, and if we measure the distance of this node point N from the B, then it is known as LB. So from the diagram we can say that this total distance L is equal to LA plus LB. Now the natural frequency for these two rotors, that is A and B, should be same. Now how to find out the natural frequency for the rotor? So it is 1 by 2 pi under root of Gj by IL. Now G is common, that is it is known for the shaft, then J is also common because it is related to shaft. But I and L, that is the mass moment of inertia for these two rotors, is different, Ia and Ib, and L, that is the length, is also different from the node point, that is LA and LB. So we will write here 1 by 2 pi under root of Gj divided by Ia LA, which is equal to 1 by 2 pi under root of Gj divided by Ib LB. So when we simplify this, we will get Ia LA is equal to Ib LB. So again if we simplify, then we will get the relation in between LA and LB. So LA is equal to Ib by Ia LB. So this is the first relation, that is this is the equation useful for the calculation purpose. And the second equation, L is equal to LA plus LB. So this is the equation that is also useful for the calculations. We will move to the next point, torsionally equivalent shaft. Now if we observe this diagram, for this two rotor system, the shaft with different diameters. So these diameters are D1, D2, D3, and with different lengths. D1 is having length L1, shaft with D2 is having length L2, and shaft with D3 is having length L3. Now when this shaft is replaced by equivalent shaft. So how we can consider this theoretically equivalent shaft? So for this equivalent shaft, the diameter must be uniform and length should be appropriate. So here is D equivalent, that is equivalent diameter, and this diameter is uniform all over the shaft, and this L is L equivalent. So how to find out this D equivalent and L equivalent? So when we replace such a shaft with different diameter and different lengths with equivalent shaft of uniform diameter and appropriate length, then the shaft stiffness KT should be same. So for these two systems, this stiffness KT should be same. So for this shaft, stiffness is KT, and for this equivalent shaft also the stiffness is same, that is KT. Now when the torques are applied to the rotors in opposite direction, then there is the angle of twist. So how to find out the angle of twist in this shaft with different diameter and different lengths? So suppose angle of twist for this shaft is theta, then theta, how to calculate this theta? So theta is theta 1 plus theta 2 plus theta 3. So angle of twist theta 1 plus theta 2 plus theta 3. So in this way we have to calculate the angle of twist theta. And for this equivalent shaft, angle of twist we will write as a theta equivalent. Now when these two shafts are equivalent to each other, then the stiffness KT should be same. In the same way, angle of twist theta is also should be same. So these are the two conditions for the torsionally equivalent shaft. We have formula for torsional stiffness. KT is equal to T by theta, which is equal to Gj by L. So angle of twist, that is theta, is same, that is theta is equal to theta 1 plus theta 2 plus theta 3, and which is equal to theta equivalent. So we will find out the formula for theta. When we simplify this, we will get theta is equal to TL by Gz. Now when we apply this formula, that is the angle of twist for these two shafts are same, then theta is equal to theta equivalent, which is equal to theta 1 plus theta 2 plus theta 3. Now we will put the value of theta, that is TL by Gz. So this is the formula. Now if we observe T, that is the applied torque, should be same as well as G. So G is the modulus of rigidity, and that is for the shaft material. So these two parameters T as well as G are same for each shaft. So we can say that L by J equivalent is equal to L1 by J1 plus L2 by J2 plus L3 by J3. Now what is this J? That is the polar moment of inertia for this shaft, and we know that J is equal to pi by 32 d raised to 4. So this pi by 32 is common term. So we can cancel this pi by 32 on both the sides. So what will remain? So L equivalent divided by d raised to 4 equivalent, that is d equivalent raised to 4, which is equal to L1 by d1 raised to 4 plus L2 by d2 raised to 4 plus L3 by d3 raised to 4. Now how to find out the equivalent length? So L equivalent is equal to, we can transfer this d equivalent raised to 4 to the right hand side. So final formula, L equivalent is equal to d equivalent by d1 raised to 4 into L1 plus d equivalent by d2 raised to 4 into L2 plus d equivalent by d3 raised to 4 into L3. So this is the final formula to find out the equivalent length of this shaft.
Given question, two identical rotors are attached to the two ends of a stepped shaft. Each rotor weighs 450 kg and has a radius of gyration of 0.38 meter. The diameter of the shaft is 0.75 meter for the first, 0.25 meter length, 0.1 meter diameter for the next, 0.1 meter length, and for the remaining length 0.0875 meter in diameter. The total length of the shaft is 0.6 meter. Find the frequency of free torsional vibration of the system and the position of the node from either masses. Assume modulus of rigidity as 80 into 10 raised to 9 Newton per meter square.
Let us understand given data with the help of diagram. For a stepped shaft, the length is given 0.25 meter with diameter D1 0.75 meter. The next section, length L2 0.1 meter, diameter D2 0.1 meter, L3 0.25 meter and diameter D3 0.0875 meter. Now the two rotors A and B are identical. We will calculate the mass moment of inertia for these two rotors. Now we know that these rotors rotate in opposite direction. So if I show here the direction of rotation, then these two rotors rotate in opposite direction to each other and therefore the free torsional vibration occurs in the system. So how to calculate the mass moment of inertia? I is equal to mk square, where m is the mass of rotor, k is the radius of gyration of the rotor. Now this information is mentioned in the question, so we will put the value. So Ia is equal to Ib, which is equal to 450 into 0.38 square is equal to 64.98 kilogram meter square. Now if we observe, the diameter and length for this shaft is different. So this is the actual system as per the given data. Now we will develop here the equivalent system. So how to develop the torsionally equivalent shaft? So we know that we have to mention here the length of the shaft, that is L equivalent, with equivalent diameter, that is D equivalent, for which the torsional stiffness should be same for these two shafts. That is, this is the actual system and this is the equivalent system. Now we will consider here the equivalent diameter. So I will provide you here one hint how to decide, or we have to assume one particular value for this equivalent diameter because it is not mentioned in the question. So we have to choose any value in between these three diameters, that is highest value is 0.75 meter, that is diameter, and lowest value is 0.0875. So we can choose any value in between these two diameters. So we will assume here the equivalent diameter, that is equal to 0.2 meter. Now for this shaft, that is for the equivalent system, we have to find out the equivalent length, that is L equivalent. So how to find out this? So we have formula, L equivalent is equal to. Now if we observe the actual system, there are three lengths, that is L1, L2, L3, and there are three diameters, D1, D2, D3. So we have to consider these three lengths, three diameters, and this is assumption D equivalent. And L equivalent is equal to L1 in bracket D equivalent by D1 raised to 4 plus L2, D equivalent by D2 raised to 4 plus L3, D equivalent by D3 raised to 4. Now when we put the values, because all values are known, then we will get the answer L equivalent is equal to 8.4251 meter. So we will mention here it is value is 8.4251. Now we will find out the natural frequency of torsional vibration. Now the given question is for two rotor system, and these rotors rotate in opposite direction and therefore the amplitudes of the vibration are also in opposite direction. So we will show here this amplitude of vibration. So for rotor A, if we show the amplitude of vibration is in the upward direction of this horizontal line, that is we can say shaft, I will show here the amplitude of vibration is A1, and we have to show the amplitude of vibration for rotor B is in the downward direction, that is in the opposite direction. So we will show here the amplitude A2 for this B. So here is rotor A and here is rotor B. Now if we connect the end points of this A1 and A2, then we get the point of intersection on the shaft, and this point of intersection is known as node point, that is N. And at this node point, amplitude of vibration is 0. Now if we measure the distance from the rotor A to N, then it is known as LA. And if we measure the distance from rotor B to N, then it is known as LB. Now what is the formula for the natural frequency for the two rotor systems? So we know that the mass moment of inertia for two identical rotor is same, that is IA is equal to IB. Then G, that is the modulus of rigidity for the shaft material. So for the shaft material, value of G is given in the question. So this IA and IB is also calculated, G is mentioned in the question. Now J, that is the polar moment of inertia for the shaft. So for this polar moment of inertia, we have to calculate this for the equivalent system. So remember this node point that I have shown here, that is for equivalent system. This is the actual system and this is the equivalent system. And the node point, that is the location of node point, is for the equivalent system. So here we have to calculate J for J equivalent. And what is the formula to calculate for the shaft? That is pi by 32 D equivalent raised to 4. So this is the formula and we can calculate here the J equivalent. Now what is the formula to find out natural frequency? That is 1 by 2 pi under root of G J equivalent by IA LA is equal to 1 by 2 pi under root of G J equivalent divided by IB LB. Now this LA and LB is not known because the actual location of the node is not known for the equivalent system. Now if we observe the diagram, then we can say that this L equivalent is equal to LA plus LB. So we will get one equation. Now another condition, we know that IA LA is equal to IB LB. But for these two identical rotors, IA is equal to IB. So this is getting cancelled. So we can say that LA is equal to LB. So we will get this another equation. So if we solve these two equations, that is LA is equal to LB and L equivalent is equal to LA plus LB. So instead of LB, if I put LA, then we will get L equivalent is equal to 2 times LA and L equivalent is 8.4251. So value of LA, that is value of LB, we will get 4.2125. So we can mention here LA is equal to 4.2125, and in the same way LB is also equal to 4.2125. So we will get LA and LB. So we can easily calculate this natural frequency. So we can take any one formula. We can take this first term or we can take the second term because both are equal. So when we put the values, then we will get the answer, that is 34.1008 Hertz. Next question, we have to find out the position of node in the actual shaft. In actual shaft, there are different lengths L1, L2, L3. So we have to first cross check on each shaft what is the position of node, and that's why we will make here the assumption on the first shaft the position of node will be at a distance of x. So this is the start point of this shaft 1. So I will consider here the distance x. So at this point there will be the position of node. So how to calculate this x? So we have formula. So we will take here LA because this x is from rotor A, because we will calculate the position of node from the rotor A. So we will take the LA for the which we have calculated for equivalent shaft. But we have to now decide the position of node in actual shaft. So this LA is equal to X D equivalent by D1 raised to 4. So which is equal to, now we will put value, LA value is known, D equivalent that is 0.2 and D1 is 0.75. So when we calculate, we will get this unknown term X, that is 833.08. Now this X is related to this L1. Now if we compare the value of X and value of L1, then this X is much greater than this L1, and it is not possible because the node should lie within the length L1, and this is not possible. So we cannot say that this node point will lie on the first shaft. So we will remove this. Now we will move to the next shaft. Now we will consider the node point will lie on the second shaft. So here is the starting point of the shaft. Now from the starting point we will consider the node point will lie on at a distance x. So this is the distance x meter. Now we will calculate this x. So how to calculate this? So this x, we are going to calculate this point from the rotor A, and that's why we will consider here the LA. So LA is equal to, now from rotor A there is the first shaft. So for the first shaft, how we can write here, that is L1 into D equivalent by D1 raised to 4 plus, now here is the node point, so we will consider only x, that is x into D equivalent by D2 raised to 4. Now when we solve this, because we know what is this length L1, D equivalent D1, and then here is also D equivalent and D2, so only unknown term is x. So when we calculate x, we will get 0.2632. Now if we compare this with D2, then L2 0.2632. So this value of x is much greater than L2, because if we compare, L2 is 0.1 and x is 0.26. So this is not possible because x, that is the value of x, should lie within this L2, and therefore this node point does not lie on the second shaft also. So we will remove this. Now we will check for the third shaft. So we will consider the node point will lie on the third shaft. So this is the starting point, and we will consider this node point will lie at a distance x on the third shaft. So how to calculate this value of x? So we are going to find out the distance from the rotor A. So we will use here LA is equal to, now after A there is the first shaft. So we will write here L1 D equivalent by D1 raised to 4. Then there is the second shaft. Therefore we will write plus L2 D equivalent by D2 raised to 4 plus. Now we have to calculate this x. So we will write x into D equivalent by D3 raised to 4. Now we will put all the values. So when we put all the values, there is only one unknown term x, and when we calculate x, x is 0.0956. Now we will compare this value with L3. So L3 is 0.25. So this x is less than 0.25. So this value of x, that is the node point, will occur on the shaft number 3. So we can say that we will show here this distance, that is the node point occur at a distance of 0.0956. So this is the distance on the shaft number 3. So what is the total distance from the shaft A? So we will find out this with the help of diagram. So 0.25 plus 0.1 plus 0.0956. So when we calculate this, then we will get 0.4456 and unit is meter.